So if you look here, it says state the number of complex zeros, the possible number of real and imaginary, the possible rational zeros for this function. I will say on your quiz, those may be combined. I just wanted to make sure that the ones that you're factoring were something that you could factor with either difference of cubes or quadratic formula or something like that, so that you had something you could do there. So for this one, it's separated. For this, you're going to say the total number of zeros, so the total number of complex zeros, which is real and imaginary put together. So the total number is going to be whatever your degree is, right? Mm-hmm. So this one is just going to be 5. I always start with imaginary. So I would say for the number of imaginary you're going to have, remember they come in pairs. So you could have, at most, an even number less than 5, equal or less than 5. So at most, you could have 4 or 2 or 0, because they come in pairs. They have to be even numbers. Okay? Make sense? Mm-hmm. And then the real, well, the real and the imaginary have to add up to the total. So if I have 4 imaginary, then I'm going to have 1 real. If I have 2 imaginary, I'm going to have 3 reals. And if I have 0 imaginaries, I'm going to have 5 reals. Okay? Because they have to add up to the 5. So if my imaginaries come in pairs, because they are square roots, they can only be 0, 2, 4, because that's the most I can get in even numbers. And then my real has to, if this is 4, that's going to have to be 1, because it has to be 5. If that's 2, that's going to have to be 3. For 5, 0 and 5, 5. All right, so the last one is list all the possible rational. This comes from the constant, all of those factors over the leading coefficient factors. And so these possible rational would be that list. And they're all over 1. If you had something other than 1 up front, you'd have to put them all over that one too. But my factors of 8 are 1, positive and negative 1 over 1, positive and negative 2 over 1, positive and negative 4 over 1, and positive and negative 8 over 1. If that were 2 in front, you would have to put every one of those numbers over 2 as well. Now, if it repeats, so like if I put 4 over 2, that's just 2. I don't need to list that again. But 1 over 2 is 1/2. And so then I would have positive or negative 1/2 potentially if that was a 2 in front. So remember your factors of your leading coefficient as well. Zeros, 1 has been given. They gave me the 0 of 3. Remember, when they give it to you, you do not have to change the sign. Okay? Only when they give you a binomial do you make it opposite. So we are going to do synthetic division here with a 3. So we're going to say 3 is what we're dividing by. Remember, you have to make sure you have x to the 4th. X to the 3rd. We don't have an x squared, so what do we need to do here? 0. And then 64, and then negative 192. All right. So for this one, we add down, we get a 1. Multiply up, we get a 3. 0, 0, 0. Keeps zeroing out. 64 times 3 is positive 192. If you do not get a remainder of a 0 from the one they gave you, you did something wrong. Okay? So if you do not get a remainder of 0, you divided wrong. So if I'm finding all of my zeros, I know that I have a 3. And then I'm going to look at this. I started with x to the 4th, so this is x cubed. X squared is 0, x is 0, and then I have 64. All right. I need to find where this is 0. This is a special case. This is a sum of cubes. Yes, sum of cubes. A plus b, a squared minus ab plus b squared. So you do need to know your factoring. All right, so I'm going to factor this guy. My a is x. My b is the cubed root of 64, which is 4. So I'm going to use, this is my a, and this is my b, and I'm going to factor it. I have a plus b, a squared, so that's x squared, minus a times b, so that's 4 times x, plus b squared, which is 16. I need each one of these equal to 0. So when I set x plus 4 equal to 0, I'm going to get x equals -4. That is another 0 that I have, -4. So I can put that one down on my list. When I set this equal to 0, I'm going to need to use the quadratic formula because remember, anytime you do difference or sum of cubes, your trinomial is not factorable. There are no factors of 16 that add up to 4. So you're going to have to use quadratic formula when you set this guy equal to 0. So you're going to say -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then you're just going to solve this guy here. You are going to get an imaginary number here. 16 minus 64. You'll get a negative, right? What do you do with that negative, by the way?
Bring out an I.
Yeah. So you're going to bring out an I. And you need to simplify this. So 4 is going to simplify. Yeah. If you don't know, just use your factor tree. It's going to be 16 and 3, hopefully. I think 16 and... No, maybe not. What did I do wrong? 2 and 6, 2 and 3. So we have a 4 plus or minus. I have 2 and 2, so a 4 comes out and an I comes out. A 3 stays in all over 2. You can reduce all of that by 2, right? So your last one is going to be 2 plus or minus 2i square root of 3. Those are my zeros. Just to double check here, I have 1, 2, 3, 4 zeros. I have a degree of 4. This is correct. And I have 2 imaginary and 2 real, which makes sense because my imaginary came in pairs. And then my real added up to the degrees. In this section, and this is how it will be on your quiz, we've already done this process with just real numbers and rational numbers. So your quiz will have irrational or imaginary because those all come in pairs. So if you have a square root, your conjugate of your square root should also be a 0. If you have an imaginary, your conjugate of your imaginary will also be a 0, okay? So they gave you 2 zeros, but you should have a third one assumed because of that square root, okay? So here they gave you 3 square root of 6. You need to also assume negative square root of 6 as a 0, okay? So that when you set this up, you're going to say x minus 3, x minus the square root of 6, and x minus the negative square root of 6. So that you have 3 zeros there. Even though they only gave you 2, you have to assume the third one because irrational and imaginary always have a partner, okay, that you have to assume the conjugate of. And as always, I'm going to multiply conjugates first because they're special cases, a plus b, a minus b. So I'm going to leave this x minus 3 alone for right now. This guy is going to always be the first one squared. Your middle terms are going to cancel. Positive x squared of 6, negative x squared of 6. And then subtracting your last one squared. Square root of 6 squared is just 6. So conjugates will always foil that way. You're welcome to foil them if you don't remember that. But they will always foil with the first one squared minus the second one squared. It's a special case that we learned in our factoring chapter. All right, conjugates will always cancel out the middle terms. It will only be the first term squared minus the second term squared, always. Once you've done that, then you can just FOIL as always. Distribute your x. So you're going to get x cubed minus 6x. Distribute your negative 3. Negative 3x squared plus 18. And then, of course, you want to put it in standard form. So you're going to have x cubed minus 3x squared minus 6x plus 18. And this is the polynomial you are looking for. Degree of 3, that makes sense because I have 1, 2, 3 zeros. So I should end up with a degree of 3 there as well. Right here, I need to see either permutation or combination, or you can write your abbreviation for what you're doing, P or C, for how you're actually doing this particular problem. Brenda and Wilbur are planning trips to 3 countries this year. There are 6 countries they would like to visit. They are deciding which countries to skip. Now, okay, so in my brain, order would matter here just because my brain would look at a map and be like, I need to do this in a certain order. But that's not what they're talking about. Order doesn't matter here. Which countries they skip, it's all the same. We're not talking about the way in which they travel, okay? Skipping countries, if they skip 3 countries, it doesn't matter which order they skip them in. It's the same 3 countries that they skipped. The changing of the order didn't change the group itself. Unlike first, second, and third place, if I change the order, it significantly changes what I just said, okay? So in this case, order doesn't matter. So which one is this going to be? Yeah, so it's a combination. So this is a combination. And then how am I going to set it up? Well, what's the total number of countries? The total number of countries are 6, right? They're deciding which countries to skip. 3, a combination of 6 things taken 3 at a time. You should get 20 there. It wants you to expand. I will say if I had just to the third, I may use Pascal's triangle because I think I remember it, you know. But if you don't, I mean, you can either draw out Pascal's triangle, right? My third one, or you can use your combinations. Combinations 3 and 0, combinations 3 and 1, combinations 3 and 2, combinations 3 and 3. All right. This one is a little bit different because it has 2 minus y. So pay attention to this one. You're used to like variable and then constant. So in this case, whether you use the combinations, if you use the combinations, you're going to get 1, 3, 3, 1. Or if you do Pascal's triangle, obviously you're going to get 1, 3, 3, 1 here. So my coefficient for my first group is going to be 1. I'm going to take 2 to the third power and negative y. Please write negative y there, okay? Don't forget your negatives. That's going to throw off everything to the 0. My next coefficient is 3, and it's going to be 2 squared and negative y to the first. My next coefficient is also 3. I'm going to say 2 to the first, negative y squared, and then and then a constant of 1, 2 to the 0, negative y cubed, all right? So, and then I'm just going to simplify. 2 cubed, so I have 1 times 8 times, I have this negative 1 here, by the way. So this is going to end up being negative 8. No, this is a positive 1, sorry. Negative 1 to the first power, positive 1, so I have positive 8. My y to the 0 is just a 1, so it's gone. Here I have 3 times 2 squared is 4 times negative 1 to the first power is negative 1, and I also have my y. So I have negative 12y. Here I have 3 times 2. Here my negative 1 is squared, so it becomes positive 1. So I just have a positive 6, and I have a y squared. And then here I have 1, 2 to the 0 is 1. Negative 1 cubed is negative 1. So I end up with negative y cubed. Now your answer key leaves it that way. My answers will always be in standard form, okay? So standard form here would do a negative y cubed plus a 6y squared minus a 12y plus 8. But for this case, because you're expanding, I will take it either way. But this is standard form here. So let's say I had to the 5th power. What I would do instead of drawing Pascal's triangle, I would just do this 6, 5 to the 0, 5 to the 1, and I would do all these and write my coefficients out here, and then I would just write them here. Does that make sense? So I would do my combinations over here and figure out what this is. And I would just figure out what my coefficients are going to be in that order, and then I would just drop them in place. Or you can write them out and say, okay, this is a combination of 3 things taken 0 at a time, Combination of 3 things taken one at a time. So you can do it however you want. I'm just saying Pascal's triangle and your combinations give you 1, 3, 3, 1.
Yeah, I was wondering where you got that.
So they both give you the same thing. Either way, I just showed you both ways. So if I had something to like the 9th power, over here, I would do my combinations out and I would just get what my coefficients are going to be. And then I would just plop them into the binomial theorem. Just so it's, because I feel like when you throw the combinations in there, you kind of get lost in all the chaos of it. So I do my combinations over to the side and figure out my coefficients. This says a fair coin is flipped 7 times. What is the probability of the coin landing tails up exactly 5 times? All right, exactly 5 times. So the probability of tails, that's what we want. That is going to be 1/2 or 0.5, like whatever you do in your calculator, I don't care. The probability of heads then is also 0.5. All right. We are flipping it 7 times. We want exactly 5 tails, right? So I'm going to have a combination. What I want is my P, or my tails, okay? And I want that how many times? Exactly 5, right? What I'm not trying to get is heads, which is also 0.5. If I'm doing it 7 times, that will be 2 times, right? So altogether, I should get 7 answers because I'm flipping it 7 times. So for my combination, this guy is going to be 7. The second one should match the second group, what I don't want. So 7 things taken 2 at a time. All right, so this is what I want. This is what I don't want. All right, and the probabilities for each. To the power of what I want and what I don't want, how many times I want it, how many times I don't want it. And then your combination should be the total taken what you don't want at a time. Okay? So when you plug all this in, you're going to get something like 0.164 if you round it to the third decimal place at that point. In percentage, which is what I'm asking you for, is to the nearest tenth of a percent. It's 16.4%. I would put it all into your calculator. This is 0.5, so it's going to probably round nicely. If you round and round within your problem, then you're going to get further off on your rounding. So it's best just to put it all in and then round at the very end.